gonna fail. I had up at MSU anyway.
So, who's looked at my Notre Dame and knows what's coming? Okay. So, homework quizzes today. If you haven't looked at my Notre Dame, it's been up there the whole week. Before we start that, let's take some questions from homeworks. So this homework quiz is going to be covering just the worksheets 1 and 2 that we've done as homeworks. Okay. Let's start with worksheet 1 questions first and just kind of try to move slowly in order. I know, Emily, you'd asked about a worksheet 2 thing. I'll definitely do that. I just want to kind of go slowly and systematically and not be jumping back and forth between the two. Okie dokes. All right. Nick, should we start with you then?
Yeah, number 11.
Number 11. Okay. So first thing that we like to do is to figure out where on my unit circle 3 pi to 4 pi is covering. That's correct. So if we just kind of walk around our unit circle, so 0, half, 1 pi, 1.5, to 2 pi, 2.5, 3 pi, so that's where we're starting, to 3.5, to 4. So 3 to 4 is quadrants 3 and 4. Is everybody okay with how I did that? Just counting, right? By halves. Every quadrant is a half. And I just kept going around until I got there. Now, this equation is tangent equals root 3 over 3. On the unit circle, what is tangent? Y over x. Do you need to remember that? Yes. So I know that y over x is equal to root 3 over 3. Now I might think to myself, okay, well, I'll go look for a place where y is square root 3 and x is positive, or is regular 3, right? If I go and I look on the unit circle, there's no place like that. So there must be a little trick to this one then, right? So here's the trick. I'm going to reduce this fraction. Square root 3 over 3. How does that reduce though, Mr. Kulik? Well, regular 3 is the square root of 3 squared, right? So I can reduce then a square root of 3 from the top, leaving just a 1, and a square root of 3 from the bottom. So now if I look on the unit circle for a place where the x-coordinate is a square root of 3 and the y-coordinate is a 1, I still don't see that, but hold on one second here. Oh, yeah, sure. But if I look, come on. I do see places where the numerator on the x-coordinate is a square root of 3, and the numerator on the y-coordinate is a 1. So what I'm going to do then, I notice that in those locations, the denominator for both x and y is the same. So what I can do is I can go back here, and I'm just going to multiply the top and bottom by 1/2. that's going to turn the 1 into 1/2 and the root 3 into root 3 over 2. And now those are coordinates on my unit circle. So last thing I'm going to do, so I can say, okay, well, x should be root 3 over 2, and y should be 1/2. But what happens if I go looking for those two coordinates in quadrants 3 and 4? Let's go see. So I have this where x is negative root 3 over 2 and y is negative 1/2. Well, that's not right because they're not both positive. And over here I have x is positive root 3, but y is negative 1/2. That's not what I said either. What's going on? Did I make a mistake? No. Let's go back and look 1 second and see which one I really want here. So here I have that x or y divided by x is a positive value, right? So surely that's the case if x and y are both positive, but also would be the case if x and y are both negative. And that was one of the places that we saw in quadrants 1 and 2. Ding, 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 ding. So that's what I want, is this angle 7 pi over 6. But I'm not quite done yet because there's one more thing I still need to check. Is I need to check to see if 7 pi over 6 is between 3 pi and 4 pi. Well, the fraction 7 over 6 is 1 and 1/6, right? 1 and 1/6 is not between 3 and 4. So this answer that I've given is not completely correct yet. What do I need to do to it? I'm going to add 2 pi and see if that'll get me there. And I'm going to keep adding 2 pi until that's big enough. Or if it was too big, I would be subtracting 2 pi. Yes, sir.
See if it's like bigger than pi. Can't we just like 7 pi divided by 6? And if it's 3 pi,
yeah, absolutely. Yep. So let's see. So 1 and 1/6 plus 2 gives me 3 and 1/6, right? That's going to be between 3 and 4. So this should be my answer, right? To add these, what do I need to make? Common denominator. What would the common denominator be? 6. So when I multiply 2 pi over 1 by 6 over 6, that turns into 12 pi over 6. So when I add the numerators, I get 19 pi, and the denominator stays as a 6. And that should be my final answer. Nick, does that feel good? That's like the worst case scenario there, right? Like that had all the bells and whistles on it, where it was a tangent one. It was hidden that what x and y needed to be. And then the x and y were actually had to both be negative, even though it didn't look like it in the problem initially. And then the answer that we got wasn't in between the interval we needed, so we had to add or subtract 2 pi. So that was like the worst case for one of these kinds of problems. So this had, like, again, all the problems you could run into on one of these no calculator, just use the unit circle kind of problems. Does that feel okay?
Yeah.
Good. Other questions from worksheet 1 that we want to talk about before moving on? Yes, Alondra? 6? Sure. Okay. So 6 is a little different because notice we're not given an interval to work with, right? We're just told sine of theta is one thing and cosine of theta is another thing. Well, on the unit circle, what is sine theta? Y. And on the unit circle, what is cosine theta? So all I'm going to do is now look on my unit circle for where the x is 1/2 and the y is negative root 2 over 2, or negative root 3 over 2. So if I look at that, x is 1/2 and y is negative root 3 over 2. So my answer should be 5 pi over 3. And that's it. Does that feel okay, Alondra? Notice on these ones with the unit circle, really you can do these with nothing written down at all, right? You should be able to, once you've gotten the hang of this, you should be able to look at the problem, go to the unit circle, find the angle, write it down. You might have to like add 2 pi or something to it and do that part by hand, but there's really shouldn't be a lot of that you need to write calculation-wise to do these kinds of problems. You know what I'm saying? It's just like find the right spot on the unit circle, write down the angle, and you're kind of done. There's not a lot to do. The tangent ones sometimes get a little tricky, and I can understand wanting to write down some stuff there. But the sine and cosine ones are usually pretty obvious. Does that feel okay? Good. Should we move on to worksheet 2? Okay. I only am pushing because worksheet 2 we haven't taken any questions from yet. This is the second day we've taken questions from worksheet 1, so I would expect that to be a little bit clearer for everybody as we've done that a couple of times now. Okay, on worksheet 2, what do we got? Emily, we'll start with you because you asked me in the hallway on the way in. Okay. Should we do 1 then? Okay. All right. So to do any of these problems, I want to first start by drawing my picture, right? Because the picture is going to be what gives me the equation that I need to write to type into my calculator. So I'm going to start by figuring out what quadrants are covered by my interval. I notice that the angles, pi over 2 and 3 pi over 2, are positive. So when I'm doing my counting, I'm going to be counting counterclockwise. So I start at 0, and then every quadrant is 1/2 of a pi. So going from pi over 2 to 3 pi over 2, we covered quadrants 2 and 3. Okay with that? Now to narrow this down, I'm going to consider that sine theta has to equal 0.11, which is a positive value. So I'm going to use my acronym all silly turtles crawl to help me identify what quadrant sine needs to be positive in. Remember, these letters stand for the trig functions that are going to be positive in that quadrant. A stands for all sine, cosine, and tangent are positive in the first quadrant. So that is definitely someplace where sine is positive. S stands for sine is positive in the second quadrant, but cosine and tangent would be negative. But we're talking about sine, so that includes quadrant 2 as well. T stands for tangent is positive. So sine and cosine would be negative, not one that we want then because our sine is positive. And C stands for cosine is positive, which means sine and tangent are negative, so not one that we're interested in either. So sine being positive implies that we should be looking at quadrants 1 and 2. I can see now from the overlap that my answer to be both inside that interval range and to have a positive value for sine must be in quadrant 2. So I'm going to draw my angle, the initial side always on the positive x-axis. The terminal side I'm just going to put somewhere in quadrant 2. It doesn't really matter. I usually just put it in the middle so I have enough room to write around it. And because the angles we're talking about are positive, I know theta is going to be going counterclockwise. Nick?
So if you did like a full swing like 360 and then in like quadrant 2, will like the x thing be like 2 pi?
Would probably be 2 pi would be 0, would be where 0 is, and 3 pi would be where pi is.
Okay.
So like on the next problem. So far so good. Next I'm going to label my angle alpha. Alpha always goes between the terminal side of theta and the part of the x-axis closest to that terminal side. So in this case, it's going to go right there in between my x-axis and the terminal side. It's always going to be an acute angle. Everybody's cool? So now what I need to do is I need to write an equation that relates theta, alpha, and that side of the x-axis that makes up the other part of alpha. So if I look at those three values, is theta, does that end before we get to pi, or does it end after we get to pi? It ends before, right? So I know that theta plus something else would get us to pi, right? Everybody agree with that? How much further do we have to go from theta to get to pi? Alpha, right? Because that's the angle in between theta and pi. That's the equation that I need. So the next step I'm going to do is just get the theta by itself by subtracting alpha from both sides. And then how do I calculate alpha? Yes. So it's going to be, since the problem was a sine problem, we're doing sine inverse. Because sine theta equals 0.11, we're doing the absolute value of 0.11. So that's what I'm going to type into my calculator now. Now, when I do this in practice, I never do the absolute value in my calculator. I just do it in my head because it's like, yo, I can make things positive in my head without needing the calculator's help to do that. Just saves me a bunch of buttons. So I'm going to write it down on my paper, but I never type it into my calculator. You guys should get in the habit of typing it into your calculator because you're going to forget to make things positive on your own because you're just learning to do this. I see it happen all the time. It's a super common error. And students are like, I keep getting, it's not working. Like when I check it, it doesn't, it's like, your alpha's wrong because you forgot the absolute value. Because I never do it when I type into my calculator. I try to write it on my paper every time I do it, but I usually don't type it in my calculator. Try to get in the habit of you guys typing it in your calculators. It'll make a big difference. And after like a page of doing these, you can probably stop, but like do 10 or 15 of them, typing it in every time so you get in the habit of doing it. So there's my answer, 3.03. Now, all of these problems, either from worksheet 1 or worksheet 2, are all checkable with your calculator. Right? Worksheet 1, it's usually not an issue checking because you're just pulling the thing from the unit circle and like that's your number. It's typically not an issue to check. Here though, let's check, because if you drew your picture wrong or you wrote your equation wrong, your answer will be wrong. Okay? So let's do that. To check this, I need to check two things. I want to check that sine theta does give me 0.11. So if I do sine of that number that we just got, so if I press second and the negative symbol, it does ants for me and it'll just plug the answer that I have in. So that worked. That's half of my check. Everybody's good? The other half is making sure that my answer is between pi over 2 and 3 pi over 2. Now my answer is a decimal, so to check if it's in between those, I'm going to turn pi over 2 and 3 pi over 2 into decimals also. So I'll just type into my calculator, oops, that's not pi over 2. So 303 is definitely bigger than that. And I'll type in 3 pi over 2. And it's smaller than that one. So I'm convinced that I have the correct answer because that answer gives, the sign of that answer is 0.11, and that answer is in between pi over 2 and 3 pi over 2. Does that feel okay? Oh boy. Should we do another? Yeah, let's do another, right? Again, the picture is the key here, right? If I can get to the correct picture, everything afterwards is pretty downhill, right? And to construct this picture, I'm not really doing much, right? I'm just figuring out the quadrant and then just kind of drawing in what I need. Let's go and do, I don't want to do 2 because it's the same picture. And so is that one. Here, let's do 4. I just wanted to get to one where I know the picture is going to be different. So I'm going to start the same way. I'm going to start by figuring out what 2 quadrants are covered by my interval. So I notice that those are both positive angles, 5 pi over 2 and 7 pi over 2. So when I'm counting, I'm going to be counting counterclockwise. So at 0, we're at a half, 1, 1.5, 2, 2.5, that's the start, 3, and then 3.5, oops, that's my finish. So we're covering quadrants 2 and 3. I'm sorry, yes, 2 and 3. Everybody feel okay? I'm now going to label all silly turtles crawl. And I'm going to use that to figure out where sine is negative. So I know that all stands for all of them. A stands for all are positive. I don't want that quadrant. S stands for sine is positive. I don't want that quadrant. It must be quadrants 3 and 4 that I want. So far, so good. Gonna draw my angle theta. So I know it goes in, the terminal side goes in the third quadrant. If I draw my theta, I go around one time before I get to my answer, because when I counted, I went around one time before I got to the end of that interval, right? I'm now going to draw in my alpha. The alpha is going to go between the x-axis, labeled 3 pi, and the terminal side of my angle theta, the red line. So it's going to go there. Now I'm going to want to write an equation that relates theta, that side of the x-axis that we most recently passed through, or is closest to the terminal side, and my alpha. So what I'm going to do is I'm going to look at theta and the x-axis. Is theta past 3 pi or before 3 pi? Past. So I know 3 pi plus something has to get us to theta, right? How far past 3 pi is theta? Alpha, right? Well, there we go. That equation is already equal to theta. It's time to go to our calculator. How do I type in alpha into my calculator? So sine inverse, absolute value of negative 0.86. Now when I type it into my calculator, I'm going to just do the absolute value in my head here. Yes, Joey?
Oh, when would it be 3 pi minus theta?
Well, if it was in the second quadrant again, you'd have had, it would never be 3 pi minus theta.
I mean minus alpha.
If the terminal side was in the second quadrant, like the previous example, right? Didn't we do theta, or so if my terminal side was up here, where the theta stops before 3 pi,
So if that's before,
then you'll be,
after 2 plus.
yeah.
And the same thing on the other side.
As long as the angles aren't negative, as long as the angles are positive, that's true. If the angles are negative, then it's flipped. Yeah. So the answer we got when I type into our calculator is 10.46. You guys get that when you tried typing it in?
I got 68.7.
Your calculator's in degree mode. So you find the blue button that says second. Right next to that is the mode button.
Yeah.
You need to make sure the radian option is highlighted instead of degree. So press enter when it's on radian. It'll highlight that one. If you exit out of there and try it again, you should get the correct answer now. So 1046 is what you should be looking for. Did that work, Allie? Sure. Wonderful news. Let's check our answer though, right? What we did was kind of complicated. There were lots of places to make a little silly mistake. How do we check this? So I'm going to do sine of my answer. What number should I get? Negative 0.86. Yes. And then I need to check, what's the second part? See if it's between 5 pi over 2 and 7 pi over 2. Can I do that just by looking at it? Probably not, right? I'm going to just convert those two things into decimals. What's bigger than 5 pi over 2? Yes. Let's look at 7 pi over 2. Is it smaller than that one? Yes. We did it. All right, let's do one more where the interval is negative. Everybody's okay? One more where the interval is negative. So let's scroll down and find one of those. Let's do 7. Actually, I guess they're all sine ones. Oh, let's do 12. I'm going to do 12 because we haven't done a tan one yet. Everybody's okay? So let's start by drawing our picture. Notice the angles are negative this time. So which way should I be counting? Clockwise. So 0, negative pi over 2, negative pi, negative 1.5 pi's, negative 2 pi, negative 2.5 pi's, negative 3 pi, that's the start, negative 3.5 pi's, and then negative 4 pi. So we're covering quadrants 1 and 2. I notice here that tan theta is positive. So where is tangent positive? Quadrant 3 and quadrant 1 for A for all and then T for tangent. So where is our actual answer at? Quadrant 1. So let's draw our angle. Now, to draw my spiral, which way am I spiraling? Clockwise. How many times did I have to go around? Well, once before I got to my angle, but yes. And I think you would have drawn the correct picture. So we went one time around and then to our answer. There's my theta. Everybody feel good there? Where's my alpha at? In between the terminal side and negative 4 pi, right? So we'll get there. So we're going to find an equation that relates theta, alpha, and negative 4 pi, right? Is everybody okay with so far so good? Okay. This is what makes the ones with negative angles a little bit harder. So when we did the previous ones, I asked you the question, did theta happen before or after the x-axis line? Here I'm going to change the question a little bit. I'm going to ask you, is theta bigger or smaller than negative 4 pi? It is bigger. That is correct, Emily. Why is it bigger? Because it's less negative, right? So I know that theta is going to be smaller than or is less negative than 4 pi, or negative 4 pi. How much less negative is it? Alpha less. So instead of adding alpha here, we need to subtract because we need to be making theta more negative. So my equation should be, when I add alpha to both sides, negative 4 pi plus alpha, which I think is what you said in the beginning, Joey. I just wanted to work through it slowly so I didn't leave anybody behind, but you're right on. And again, I'm not typing the absolute values in. I'm doing that in my head. So I get a negative 1107. Let's check that real quick. So I do tangent of that, and I should get the 1295, which I do. Yes. And then I need to check that that's between negative 3 pi, smaller than negative 3 pi, and then negative 4 pi, bigger than negative 4 pi. So we're good. Can I just point out to you what would have happened if you messed up that you wrote minus instead of plus? I just want to show you what would happen when we check to help you diagnose the problem. So say we wrote that as a minus instead of a plus. We get this number. And when I do the tangent of that, what did I get? I got a negative instead of a positive. If the sign is wrong, like that, the most likely situation is one of two things. Either you added alpha when you should have been subtracting, or you forgot to type the absolute value when you found your alpha. Right? So if it was supposed to be the absolute value of negative 0.86, if you forgot the absolute value and just did sine inverse of negative 0.86, same kind of thing would have happened. Now this double fails to check also, because if you check to see if this is too big or too small, what are you going to find? It's not in between, right? It's smaller than negative 4 pi. So we would have seen it's too small also. So like it double fails. But the part that's helpful to you is seeing that you just get the wrong sign. That'll tell you that, okay, either I should have done the opposite thing with alpha, add instead of subtract, or subtract instead of add, or I forgot to do the absolute value. And those are easy things to check and try. Edu. Absolutely. How do you guys feel? Better than you walked in? I hope. Think you can do it? At least some of them? We'll give it a try. All right. Take a slice at it. I like that. Let's give it the, oh my goodness, it's raining like the dickens out. You want snow?
Snow is kind of cool.
Ooh. I'll pass on all the snow. Yeah. Here's what I like about rain better than snow. Is that like when it's done raining, there's no more rain. Right? Yeah. The snow sticks around, and then I have to shovel it, or like it slows down my commute going home, and not just today, but it might do it tomorrow, and the day after, and the day after, like it's like an ongoing problem. So back in the 80s, there was a guy who was the mayor of Washington, D.C. His name was Marion Barry. And they had all kinds of budget problems with the city, to pay for stuff, and they ran out of their snow removal money, and somebody asked them, you're all out of money in your budget, what's your snow removal plan? How are you gonna do that? And it's like, my snow removal plan is spring. That's his answer. Got a lot of national attention for that because it was quite funny. Yeah.
This is the X, right? X.
Correct. Yep. If you have number, if you have version 3, Can you look at the top of your paper and see what version you have? If you have version 3, the first problem is a cosine. Can we change that to sine? Otherwise, good luck with it, you dudes. Should be just like the stuff we've been doing.